What's going on, 7th grade students? Let's get this party started with the bridge design. We're going to be finishing off this thing, and this will be the last kind of lecture I have on the bridge design. After this, we're on our own as far as doing things. So, what up, dudes? Let's get this party going. So, check this out. This was lab 1, and I basically uploaded a little sample page of what I did, right? You've done this before. You printed up this thing, you made your little sketch over here, and then you measured from I call this N0, and I labeled it -1 to 0, and then N2, which is 15,16, and N3 is 25,16, and actually N1 is over here, is 36,5, and N4 is 4,5, and all of that kind of stuff. Cool? And then I went through and I actually calculated out all of the distances. This is actually, you finish at, technically I get to have you guys until 12:15 today. But I don't think that I'm going to go to 12:15. I will probably finish way early.
I thought Mondays was 12.
No. It's Wednesdays that it has our lab day, but I'll probably finish early if we can get through it, if we don't take too many tangents. All right? But technically, I'm allowed to go to that. All right. Anyway. Oh, who's with me this time? I've got Maya Beetle hanging out with us. All right. So this is lab 1, and this is pretty straightforward. We actually talked in gross detail about how to do this on Monday, right? And then on Monday, I took lab 1 and I put in and I made a spreadsheet, and I taught you guys how to make that spreadsheet. And what I did was I took the information from here and I input it here. See, look, see this member right here from this line that goes from here to here? I'm calling that member 04 because it's connecting node 0 and node 4. Does that make sense? And then it says, then what I do is I put in that information into here, and I have, okay, it's node 0 is at -1, 0, and node 4 is at 4,5. Cool? And you're like, well, what does this do? Well, the spreadsheet will actually calculate out the length that it takes to go from here to here. Are we cool with that? So you look at this calculated length, and that's your answer right there. And then I can make this line over here, and it goes from 4,5 to 15,16. So this would be my node 4,2 because it's connecting node 2 or member 4,2, which is M42, because it's connecting node 4 to node 2. And I put in the coordinates of node 4, which is 4,5. You can see that right there. And I put in the coordinates of node 2, and that's 15,16. And then the calculator, using this formula up here, which I showed you guys how to do it in the class on Monday, will calculate out my length for that member. Are we cool with that? Like, this is all from Monday. We did this on Monday, right? So now what I'm going to do is I'm going to use this information, particularly from the drawing and from this thing, to help me design an awesome bridge in an engineering program. So I'm going to show you how to use the engineering program, and that's what our game is going to be today. So let me close this thing out. And what I'm going to do is I'm going to open up a program called, I'm going to open up a new tab, and I'm going to go to this place called, so here's what lab 3 is. And I haven't even posted lab 3 because I haven't finished writing it up. But I have it all over here. Okay? So, all right. Open up the SkyCiv Truss Analysis Calculator. So I'm opening up a new tab, and I'm going to type in SkyCiv, SKYCIV. The first thing that comes up is this: welcome to SkyCiv Engineering. It's an actual engineering program that engineers use. We're using the free demo version since we don't need to really do actual, like, a full-on bridge project and design. But if an actual engineer wanted to do it, they would probably spend plenty bucks on this thing and use the actual full calculator. Anyway, here's what the program looks like. Got it? Now, if I go back to my paper that I have, I can easily put in all of the nodes. I can easily put in all the information for the nodes. So let's take a look at where some of those nodes are. Let's see. I've got a node at -1, 0. I've got one at 4, 5, and 15, 16. Okay? So I'm going to do nodes, -1, 0. Press apply, and it will put a dot right there for me. Let's see. That's node 0.
4 and
Node 1 is actually, node 1, if we go back to our picture, is actually at 36.5 because I called that N1. Do you see the N1 right there? So that one is 36.5. Apply. So there's the other node right there. So what I'm doing is I'm using the coordinates to build a bridge. All right, so let's put in all the rest of this information.
Then
Node 2
there's
is at
15.
16, oh no,
15.
15, 16. And this is all based off of my original design, and you guys have your original designs. Some of you guys made super complicated bridges, like lines everywhere, and that's cool, but the problem is,
Can't print that.
yeah. Isabella is asking, wait, is this how we're supposed to draw the bridge? No. This is just my sample. This is the one I came up with. It's the most simple design I can come up with. But you guys get to come up with whatever bridge design you want. Oh, you draw. This is actually what you did in Lab 1. After you're done with Lab 1, this is what you're supposed to have. You print out the piece of paper and you use, you go through and you actually draw it.
Okay.
Yes, I saw yours, Sierra. Yours got like members here and then cross joints over here, and it's got a whole bunch of V's and X's in the middle. Oh man, that thing's cray. All right. No, it's good. It's good. It's just we can use your example. Yeah, I would say that don't use my example exactly. Mine's is so plain.
And it might break easily.
Yeah, mine's is not really that fun.
Mine's really.
Mine is not usually. It's not really. It's simple. I actually just went with the most simple kind of design just so I could show you. All right. So let me finish putting in all of these nodes. I'm going to build this thing for you. So node 3 is at 2516.
Yeah.
So I'm telling the computer the X and Y coordinates, and the computer knows exactly where to put the things. This is the advantage of having these X and Y coordinates. And then node 4, and notice how I have the name node 4 is going to be at 4, 5. All right, so I've got my nodes in there. Those are the points that the computer will connect to. Are we cool with that?
Now, does it draw a line or?
Now, well, okay, so that would be naming your X and Y. You put in the name and the X and Y coordinates of your node. You can use a spreadsheet to help you do this. Do this for all your nodes. Okay. Next, press the back arrow. So wait, here it is. All right. Let's just do one. All right, here we go. I'm going to press the back arrow. Now I'm going to include the members. So I included the nodes. These are like the connecting, it's almost like playing connect the dots back when you were a kid.
Yeah.
And so what we did with the nodes is we made the dots first, right? And now we're going to connect the dots using our members. So I'm going to go member 0. Actually, I can't really change the name on this one, so I'm just going to say member 0 goes from 0, 4. It goes from 0 to 4. Got it?
Mm-hmm.
Apply. And then my next member is going to go from 4 to 2. How's that?
2 to 3.
And then 2 to 3. So from node 2 to node 3, I want to draw a line. And then node 3 to 1.
Shouldn't you have started from 0 going to 1?
Well, actually, you're asking, should I have started going from 0 to 1? And here's node 0. Here's node 1. I don't want a line connecting this bottom part. If I drew a bridge so that it is diagonal all the way across, then yes, I agree with you. I would have put 0 to 1. But that's not how I designed this particular bridge. But if you design your bridge a little bit different, hey, by all means, have at it. Got it?
Mm-hmm.
The last node I need is from 4 to 1. Let's apply that.
That is really simple.
This is my simple bridge. Okay, now what I need is this bridge is floating. Okay, wait. Let me see the instructions and see.
Aren't you gonna have water under it and then like a test?
So these are members. These are members. Okay. So now what I need is this bridge is floating in space. It's not actually connected to the ground. So what I need to do is I need to... Okay. Yes, Isabella, you are literally going to print up a piece of paper that has a blank version of this. You're going to draw a bridge on it, and you're going to go through... I recorded a video to kind of give you all the directions to do this lab 1. And that one's pretty simple. It's due today, I think. And you upload that picture, and it should look something like this, or your bridge is probably going to be more complicated or whatever. I don't really care exactly how it looks. I just want you to be able to do this. But see, if you do this lab 1, that's going to help you with lab 2, which is going to help you out with this lab 3, which is what I'm talking about, the SkySieve one. So you need to do the first lab in order to get to the third one. Does that make sense to you? Okay. All right, so now what I'm doing is this bridge is kind of floating in the middle of nowhere.
You have to make
So I need to kind of connect it to the ground, and the way I'm going to do that is I'm going to do this thing called supports. Now there's 4 different kinds of supports. Yeah. The one normally comes before 2 and then before 3 and so on and so forth. Yeah. All right. So there's 4 different kinds of supports. This is called a fixed support. You see that one? This one is called a hinged support. It looks like a triangle with a dot on top. This is called a horizontal roller support, and this one's a vertical roller support. The type of support that we're going to be using is actually this one, the hinged support, and we're going to do that at the bottom left-hand corner of your bridge. So on node 0, see node 0, I'm going to put a hinged support. What this thing is it's kind of like,
But I thought we were using a block for the supports.
Well, we will be, but in the computer program, in engineering, there's, you have to tell it what kinds of supports you have.
Okay.
So what this kind of support is, this is more like a, think of it as like a door knob, not a doorknob, but a door hinge, and your bridge is allowed to rotate on that little thing. It's allowed to rotate around it, but it's not allowed to move right, left, or up and down.
That's a small support.
Well, it's just in there for the computer to know that it's there. Okay. Now on the right side over here, we're going to use a different type of support. This is where you need to pay attention. On the right side, on node 1, I'm going to put a roller support. It looks like that. This allows your bridge to not only rotate about the support, but it also allows the bridge to slide right and left. Okay?
Are we gonna have that when we actually do the real competition? Is the testing block or something like that?
Yes, in the real competition, this testing block that's on the right-hand side is actually best modeled by a roller support. And this one is best modeled by a hinge support. So that's why I'm telling you to use those. All right. What I think, Jonathan, were you confused about what I just did? I can do it again. Okay. What I did was I went into supports, got it? And on the bottom left-hand side, I want a hinge support. So it would be that triangle with a little dot on top of it. And I want that at node 0. Apply. For the next support, I would like a roller support, and I want that at node 1. I'm going to apply. And that's it. That's all you got to do. Yes, Michael, throw up your question. Go for it. Oh, by the way, that's all there is to know in terms of knowing about the supports.
Are we going to be using all of these?
No, we're not going to use all of these. I'm actually going to show you the last one we're going to use.
And
Okay.
then press solve.
The last one we're going to use. Oh, Michael, yeah, type up your question. I'm waiting for it. But while I'm waiting, I'm going to go through all of this stuff. The last one I'm going to use is called a point load system. So what I need to do is, in the actual competition, we're going to have our bridge like this, right? And then we're going to put a block on top of here, and we're going to load it up with, and we're going to hang a chain from it, and underneath this bridge, there's going to be a bucket of sand.
I thought it was going to be water.
No, it's going to be sand. And what we're going to do is we're going to pour more and more wait. You can't build your bridge on the thing. Which thing? What are you talking about?
I think he's talking about the testing.
Oh, on the graph paper? Are you talking about for lab 1? Oh, no, you print it up, and then you just draw it on there with a pencil and paper and a ruler.
What if you don't have a printer?
If you don't have a printer,
I have one. I'm just asking for the people.
oh, okay. Well, I'll tell you what. If you don't have a printer, you can let me know, and I can print up extras for you, and you can come in and get them from me. Or if you want, I can mail it to you if I need to. But I think that pretty much everyone here in this school has a printer available to them. Yeah. Ask your mom to print it up for you at work or something like that. All right, anyway. Oh, you want me to mail it to you? Okay. I'll try to do that.
Probably won't come on time.
Yeah, it probably won't come soon.
When's the lab?
Alright.
The next lab?
You can do it without a printer, can't you? You actually can. You don't need this printer. You don't need this thing. You can actually just put in all of your thing. All this lab 1 is to help you guys do the rest of the labs. But you can do it on SkySiv without anything. Anyway, let me finish my what I'm talking about. Yeah, you can actually just use regular graph paper, to be honest with you. The only reason why I made you guys print it up like this is because, the only reason why I printed up something special for you is because I wanted to put this like box right here, and I wanted to put the word testing support over here. But it could be on graph paper. If you have graph paper, just use that. Got it?
But how will we know where the testing
Yes.
block is?
Wait, you guys are asking about next week's lab. Next week's lab is next week, Wednesday. And what we're going to do is, hopefully by Monday, I'm going to have you guys actually print out for me 3D bridges. And then on Wednesday, you're going to bring in your bridges, and we're going to break them.
Oh, what?
Well, that's what the competition is. You guys are actually we're gonna put them up there and break them. I also think that it won't take up the whole lab time to break them. So I want you guys to bring in your Nerf guns, and we'll finish off the Nerf gun lab as well. Got it?
I don't have any guns.
Okay. Wait. We're getting too off topic. I want to finish this, but yes, Michael, why don't you put on your speaker so that we can hear you? But I want to answer your question. I want to move on because I want to get you guys out of here by 12:15 or 12 o'clock. Like I promised you guys, I would get you out before. So we need to finish.
Still have a whole hour.
I know. We have time. We have a lot of stuff to do. Yeah, you can draw. Let the man do his work. No, go for it. Go for it. You can ask your question. I can't hear you. Michael, you going on speaker?
Yeah, he is.
No, yeah, I can't hear you. All right. Until you ask your question, I'm going to finish off this stuff. Yes, Isabella, I have no problem with you drawing something simple. I want you to draw something, but you can draw something simple. Got it? I can start to hear Michael. Michael, ask your question.
The question? I thought I typed it.
Oh, you said, can I you said, can I turn on the mic to ask questions? So that's what I was asking.
Well, someone else was on mic, so I was just asking.
Oh, okay. All right. I'm going to finish off my what I'm going to cover then. Is that all right?
I'll just ask you any other questions when I need to.
All right, cool.
So I'll just be on speaker for a while.
No. Turn off your microphone because sometimes it's distracting for other students. But when you want to ask a question, let me know and I'll let you turn on your mic. All right, Bo. My answer to you is our next lab is next week Wednesday, and we're going to test out the bridges that we build in our 3D printer. So you actually don't need any glue or wood for this entire project. You just need a computer program. And we're going to build it in a 3D printer.
Well, I thought we were going to build it out of wood. So,
for our entire class, I want you guys to be able to get to the point where we can build it in a 3D printer. For those of you who really want to go to the next step on this one, and this is an optional part for the students, is for the people who want to compete in the competition and whatnot, we need to take this 3D model and actually build it out of wood.
Which one is stronger, wood or plastic?
Depends really on how you design it. All right, so anyway, let me finish off. So what we did was we have our nodes, we put in our members, which connect the nodes, those are the lines, and we also put in our supports. These are the green parts over here. This is the support, this is the hinge support, and this is the roller support. Now what I need to do is I need to figure out some way to simulate what it would be like if I push down on parts of my bridge. Does that make sense to you? So I'm going to go to this thing called point loads. I want to push down with 15 kilograms of force, because in the rules for our bridge design it says your bridge needs to hold at least 15 kilograms. The problem is they don't have things in kilograms here. They have things in kilonewtons. So what I did was I asked the computer, I said, all right, convert here, 15 kilograms to kilonewtons. I just typed it in the search bar and it gave me a little conversion. And I said, all right, fine. I'm going to type in 15 here and I'm going to see what I get. So apparently 15 kilograms is the same as 0.147099 kilonewtons. So what I want to do is I want to push down over here with 0.147099 kilonewtons. But what I'm going to do is actually push down over here with half of that and push down over here with half of that. So on node 2, I'm going to push down with a force of negative 0.07355. And I put that in the instructions, so you guys don't need to memorize all these numbers. I actually put that right here. You need to put down with that. By the way, it wants you to put a 0 first, 0.07355, because, I don't know, the computer doesn't like a number if you don't have a 0 over there. And the reason why I have it going in the negative direction is because I want the force to be pushing down. Does that make sense to you? All right, I want to push with the same force on node 3 over here. So on node 3, I'm going to push with a force of negative 0.07355. And if I push with those two forces going down, it will add up to be negative 0.147, which is my 15 kilograms. All right, did I lose anybody? Are we cool? All right, we're all done with that. What we need to do now is we need to solve it. So we're going to solve it, and it's going to say initializing. It's going to think about wanting to solve it, and it's going to, what is wrong?
Numbers or supports?
I just solved this bridge. How is it not stable? That's not good.
Do you have it on the one that you just did?
All right, here's what I think what happened is, see, I put two members, a separate one here and a separate one here. I think I'm going to just go one that goes from here all the way to there. So I'm going to delete member 0. and I'm going to delete member 1. And I'm going to put a new member that goes from 0 to 2. Let's try solving that. What? This is junk. I actually just had this thing done.
Did you save it?
Actually, I hate to say it, but you can't save any of this stuff.
What?
The reason being is because we're using the free version.
Oh.
So you can't save. So a lot of this stuff you need to
It's
a lot of
fine.
this stuff you need to try to figure out. Let's see. What's the problem here? Let me look at something real quick. Hold on. Sorry. I want to move on to the next thing, though. Let's see. Alright, so you might send it in late. I don't mind if you send it in a little bit late. You can turn this in tomorrow if you are really freaking out about it. But it needs to come in soon because I'm grading it now, and I have a grade check due on Friday. So you can turn it in late by tomorrow, but that's it. That's all I can do. If not, I can't include it in the grade check. Give me a second. I don't know why my bridge isn't working.
So you did the same exact thing a couple minutes before bridger class, and it worked?
Yeah, see, look, there's my bridge. This is exactly what I had, what
Before?
I put in before.
Is it the same?
Okay, let's see. I want to go from 0 to 1, or 0 to 4, 4 to 2. Support 0 is going to be that. Support 1 is going to be that. This looks like it worked. It should work. Gosh, I'm so sorry it's not working.
I'm so tired.
This is the first time it's not working like that. That's a pain.
How many times have you used this?
I used this a couple times. See, look, it's exactly the same bridge.
How come the bottom one is red?
I'll tell you why.
How is it not?
Alright, I'll tell you what. Why don't we do this? Why don't we add more members to this thing? Let's make a more complicated bridge. How's about we'll go one from 4 to 3,
Oh, gosh.
and we'll also do one from 2 to 1. Let's see if they like that bridge.
Might be single enough.
Solve successful. Okay. Alright. I'm sorry that my bridge is a little funky. I don't know what happened there.
Just draw a line.
But let's see. Let's look at this bridge. So what I want to do is I'm going to take a look at this thing real quick. Let's see. I'm going to move it up. Alright, so this is my bridge, and it goes from there to there. I want to click on Free Body Diagram, or FBD, and I want to do the supports and loads, so I want to see that. I want to go to Reactions, and I want to make sure that FX, FY, FZ, and MZ are clicked. I want to click on Axio. See, this is what it wouldn't look like before, but if I click on Axio, this is what you get. Now, some of these some of these lines are green and some of these are red. Now, what does red mean? All right, well, let me tell you what green is. Green is actually a good thing. Green means that the force is pushing this thing together. It's in compression. Does that kind of make sense? The red means it's actually in tension. So what that means is it's like over here, this member is being pulled away from this node, whereas this member over here is being pushed into this node. Does that make sense? So, so that's actually, what we want to do is we want to minimize this number right here. We don't want this number to be big. And actually, this number looks huge, to be honest with you. This member over here. I have a feeling that if this bridge were actually built, it will break right here. Because this thing is pulling away with 0.07 kilonewtons. So that's a good way for us to see exactly where this thing will break and where this thing will survive. It will usually survive over here because what's happening is the pieces of wood are being pushed together. It's not like the glue has to do anything at that point. You know what I mean? Because it's almost like if you glue two pieces together and then you push them together, that's not going to break it. If you glue two pieces together and you pull them apart, like the red stuff, that's going to break it. Does that make sense? So what we want to do is we want to keep this number to a minimum. So you need to design your bridge to see how you can make these red numbers as small as possible. And that's the point of using this thing. I want you to put in this information into your spreadsheet. So I added two more members. I added a member 443, and I also added a member 21. Because my bridge apparently wasn't stable to begin with. So those of you to keep in mind, hey, you know the bridge I built, my sample bridge must have not actually been stable enough to actually, stay up. So the computer's saying you can't build that bridge because it would just fall. No, everything doesn't need to be green. That's impossible to do. But you want to make those red numbers as small as possible. Anyway, let me put in the rest of this information. And I want to show you something else that's cool.
I'm going to use the vacuum.
All right.
Where's the blue cube?
It's up there, should be.
Which cube? Does it matter?
You're going to use pink, or the red one. And one, which is 36.5. All right. The last thing I need you to do is take the information that you have in here that you got from the SkyCiv program right here. And I want you to put in these numbers into your spreadsheet. So I want you to do this. Take these numbers over here and put them in your spreadsheet right here. So for this member right here, it's 0.063. For this member right here from 4 to 2, it's 0.078, 0.078, and then for this member over here, between 4 and 1, that is actually negative 0.07. That's a bad number. Let's see, member 2-3 is in compression at 0.047. Yeah, it's bad because it's red. Let's see, I can't really see this other one. Just zoom in a little bit more. Alright, so this one's at 0.078, and that would be 3 to 1. 0.078. And then the inside ones from here to here, you have 0.031. And then over here to here, you have 0.023. All right. The last thing I need you to do is take a picture of this thing using a screenshot, because we can't save this. So we need to have all this information. So I think that you guys can take a picture of it. I actually can't because I'm using the picture of recording screen mode. But take a picture, a screenshot of this, and that's what I want you to upload to your thing. So I'm going to ask you to upload a copy of this, and you can't save anything, so you have to take a picture of this and then recreate it if you need to later on. All right, are we cool with that? So that is the complicated SkySieve program. It's not really that bad once you get the hang of it. It's pretty cool, actually. All right, I'm going to stop recording.